Okay, so in this lesson we are going to talk a very important concept which we will later use for polymorphism. This concept is upcasting and downcasting. So it's also related with inheritance. So we have seen here that when we create a class, we have right now what we have is a class person and then a class student, which is deriving or is a child or a subclass of class person. So we have seen this before. And now we know that when we create an object of class student, they an object of class person is the base class or a superclass. So an object of class student contains, in one sense, or inherits all the properties of class person, and that's called is a relationship. So we can call a student is a person, which is a very important concept when we talk about downcasting and upcasting. So let me remove this code here. So now we know that we can create a person object and using the default constructor, and we call a method print on for class person. This is also sometimes called sending a message. So we are sending a message print to class person, which is calling a method on an object of class person. So if I run this code, it builds fine, and we can see here that person class default constructor call, person ID equals 0, name equals John. Now for demonstration, I'll also create a student object, again using the default constructor, and call print or send the message print to the student object. And when I run this code, we can see here the person class default constructor is called, student class default constructor is called, and then we are printing the information about the student, including the print. We are calling the print of person also. So we have seen this in previous lessons. Now we know that we can create a reference. So I will start with references and later look at pointers also. So I can create a reference. We have talked about this also in a previous lesson. I'll call it person ref, and this person ref is actually must be referring to an object of class person, and then person ref is actually same or referring to the same object as this person object we created on line 8. So if I print here, of course we don't for now, let me comment this code so you can see when we create this person ref, we know that we are not creating a new object, so there is still only one object that we are talking about. So when I run this code, we can see two prints. So for line 14, we are only creating a reference and not an object, and that object is pointing, or not pointing, but referring to an existing object, so we don't see the constructor being called. Now let's try to change this object so that we can see that this both a reference and the actual object are pointing or referring are talking about the same object. So if I say person, I think we do have some mutators. Actually we don't. So let's create some mutators. They will be helpful later on also. So we know that a mutator is a void function, which we will call name, and it takes in a string name. And since we are going to change the object in this case, so we cannot have a const here, so this is mutator for name, and then we will also have a mutator for ID, so it takes an int ID. Now usually these names we are reusing again and again, so this ID means the variable, the name of the method, and this is the parameter ID. But that's okay, that's hopefully it's not confusing. So now we will refactor at the definition, and our instance variable has an underscore, because remember that's the C++ style guide we are following. So that as underscore equals parameter name, and then we will also add the definition for the mutator for ID, and it's equal same. Okay, so now we have oops, okay, this code is not complete. So now we have a mutator, and now we can use, I think it needs to rebuild so it knows that we have a mutator. So I'll just rebuild the project. Okay, so now person dot name, the name. Now we have two versions of this method, so we can say control space, and control space is for autocomplete, but that then shows that we have two versions or two overloaded methods with the same name and different signatures or different interfaces. One which takes a parameter, which is our mutator, and this is a accessor method which returns a string. So we will use this, and we will set the name to Bob, and we will also set the ID. Again the same thing here. You can see we have two methods, ID, one the mutator method and one is the accessor method. So ID we will set as 1 2 3. Okay, now when we print the person, we can compile this code, and it looks like there are a couple of warnings related to initializations in the constructor, which we will ignore for now, and then we will run this code. So we can see here that after changing the name and ID, when we print this on again line 20, we see that ID is 123 and name is Bob. Now the interesting thing is since person and person ref are same objects, if I print it again the person ref, we see that person ref line 21 prints the same line, which is exactly same information as the person object, because there is only one object. We don't have two objects. Person ref is only a reference. So I hope this concept is clear. We have discussed about this earlier also. Now the interesting thing is that we can also create so I'm going to create this student object later on here. So I create a student object and call student.print on this, and now the what I want to show you is this, that person ref is we know that it's a reference to a person, and what we want to do is now, because a student is a person, we have talked about this, so we can actually refer to, or a person reference which we created here can actually refer to a student object, and compiler is fine with that, because actually all the attributes that are in the person, they are also available in a student. There is a limitation though. When we see person ref dot, we still see only ID name. We don't see the GPA and major that we have added to student, although this is actually the person ref is actually referring to a student object. So I'll show you this. I think in student constructor we have not changed the name of the student, and just for the sake of learning, what I'm going to do is, when we call the person object, when we call the default constructor for student, the default values we will give to the name and ID will be ID equals our default ID will be 9, and or let's make it -1, so we know that it's a default ID, and name is equal to student. So now this code compiles, because we should be able to do this because we created in person. We made the name and ID is protected, which means in a student class we are allowed to change this because a student is deriving from person class. So we can change the ID and name, and just so that we can see that when we create a student object, the name of the student will be student and ID will be -1. So here, going back, when we create the student object, the name will be let me show you this code here again before we move forward. So when I run this code, the ID is -1 and name is a student. So this is what we did in the student class constructor. We said that the person objects, instead of ID 0 and name John, default for student class. When we create a student object, the default ID is -1 and name is a student. I hope that's clear. Let's look at the code again here. In student's default constructor, we are changing the ID and name. Okay, just to see the difference. Now, person ref is a reference to a person object we have created here, and I'll actually break this in 2 lines because that's better. Person ref. Okay, so whenever we have a reference, we can always do an assignment, and this assignment is essentially saying that person ref, this reference is going to refer to this object. Now in this case, the object reference is of person, but the object itself is a student object, which is the student is the subclass and person is a superclass. And now this is called upcasting. What we are doing is a downcasting, where we are casting a student object or a reference to a base class can refer to an object of a derived class, because a derived class contains all the attributes of the base class. So now when I print and you'll see this code here. Okay, it's not initialized, so I think for now I have to do this on the same line. The first time you declare, you must so this shows that whenever we declare a reference, which we do here, we must initialize to an actual object, because otherwise it's not pointing to or referring to a valid object, which compiler doesn't like that. But this code is fine because here we have already declared the reference. We are only reinitializing or assigning a new value or new reference to this object. So when I run this now, you can see here that this last line, which is coming from the last print statement on line 24, this line 24, we can see this person ref is actually printing ID equals 1 and name equals a student. And just to be clear, I'll also put a C out here, and so that we can see. It's always good to make the output more meaningful, so that we can see actually what's going on. And before this, I'll print student object. Okay, so we can see here student object, person ID -1, name equals student, and person reference, we see the same output, because now person reference is actually referring to a student object. So that's very important concept about downcasting, where a reference of a base class can refer to an actual object of the superclass. Now it's important to note we cannot do this the other way. So if we say let's make a reference to a base class, to a derived class like student reference, and let's try to assign this to a person object. So we already have a person object created on line 8. So if I do this, compiler will complain, because compiler doesn't like this. You can see on line 28, invalid initialization of reference of type student from expression of type person. So this is something that compiler won't allow, that you cannot have a reference of a derived class refer to an object of the base class or a superclass. So this is important to note. This is only one way, doesn't work two ways. The other important thing is actually we could, however, do this. We could do a upcasting, since we know that this person reference is actually pointing to a student object. We could actually do a typecasting, and typecasting, so we will do study cast, and then because the cast is to a student reference and the actual object is a person reference, so we know that person reference is actually a student object reference, so we convert it into a student reference and we assign it to a student reference. So now if we type student ref dot print, now you can first of all see, because this reference is of type student, we have access to all the attributes and methods that belong to class student, including major and name. And when we print, we will see that this print will be actually printing all the attributes including the name and GPA, the GPA and the major. So I'll give this student reference, so I need a parenthesis, and when I compile this code, it compiles, and when I run, you can see here the student reference person ID equals -1, name student. Now GPA is off, and I believe that's because of our casting. So the person reference is student object, and then we have converted it to a student. So now and while converting it to a person reference and casting it to a student, we somehow have lost the values in the student variable. So and that's okay for now. We'll fix that in a later tutorial. Okay, so we'll pause here.